Hello everyone, I'm Prahalad, and this is 7th grade math with all STEM. Today we will cover part 1 of the geometry standard, which includes solving problems using scale drawings of geometric figures and understanding angle measures and side lengths in relation to triangles. As always, if you are already familiar with our video structure, you can go ahead and skip to the first question using the timestamp in the video. If you aren't, remember that each video contains 8 to 15 review questions with a step-by-step solution to each one. If you answer a question correctly, you can skip to the next question using the timestamp. If you answer a question incorrectly, stick around to watch the solution. Also, if you need some extra practice after watching the video, look in the description box for some links for further reference. Here you can find practice problems and solutions that are similar to the ones we went over in the video. Now it's time for our first practice problem. Alright, so the first practice question says, what scale factor do you have to multiply by a line with length 2 millimeters to make it a line length 6 millimeters? So you can pause the video and solve this one by yourself, and when you're ready to see the answer, you can play the video. Okay, the correct answer to this question is a scale factor of 3. So I'm going to draw two lines. This one can be length 2 millimeters, and this one can be length 6 millimeters. So a scale factor is something that you would multiply this line over here, the one with length 2 millimeters, by to get to make it the same length as the one that's 6 millimeters long. So this one is pretty straightforward. You can just do 6 divided by 2, and you get 3. And you can check that by seeing that if you do 3 times 2, or scale this line by 3, you would end up with a line of length 6 millimeters. So the final answer is 3. Question number 2 says, if the following rectangle were to be enlarged by a scale factor of 2, what would be the new perimeter and area? Okay, the correct answer to this question is a perimeter of 48 and an area of 128. So enlarged by a scale factor of 2 means each side length is multiplied by 2. So I'm going to draw out a new rectangle. And so if we multiply 8 times 2, we get 16. So that means this side would be 16 as well as this side. And then 4 times 2 equals 8. So that means this side would be 8 and this side would be 8. So now all we need to do is calculate the new perimeter and area. So the perimeter is the sum of the length of all the sides. So we can do 16 plus 16 plus 8 plus 8 plus 16 is, and we'd get 48. So that would be our final perimeter. And then the area is going to be this side length multiplied by this side length. So the length times the width. So we have 16 times 8. And we get 128. So that would be our area and perimeter. Okay, the third practice question says, when a triangle is enlarged by a scale factor of 2, by how much do the degree measures change? The correct answer to this question is 0. So this is kind of a trick question. When a triangle is enlarged by a scale factor of 2, that means the length of all of its sides are multiplied by 2. but all of the angles in x2 and all of the angles in a triangle would always add up to 180 degrees. So if you enlarge a triangle by a scale factor of anything, all the degree measures would always stay the same. So the degree measures would change by 0 degrees. So that means that's our final answer. Alright, so practice question number 4 says triangle ABC is similar to triangle ADE. If AB equals 4, AD equals 6, AC equals 5, AE equals 7.5, and BC equals 3, find the length of side DE. So for this question, you can see that there's a model of the triangle on the right, and you can use a calculator if you need. Okay, the correct answer to practice question number 4 is 4.5. So I'm going to start off by drawing both of the triangles separately. So here I have A, B, C. And over here I have A, D, E. So I'm going to start off by filling in the side lengths that they've given us. So AB equals 4, AD equals 6, AC equals 5, 7.5, and BC equals 3. So since and we need to find DE. So since they're similar triangles, each side is going to be multiplied by a scale factor. So first we need to find out that scale factor. And so to do that, we can either do 6 divided by 4, which tells us how much 4 is multiplied by to get 6, or 7.5 divided by 5. They will both get us the same answer. So I'm going to use 6 divided by 4. So our scale factor is 6 over 4, which just equals 3 over 2. So our scale factor is going to be 3 over 2. Write that at the top. And now we just need to multiply this side, BC, by the scale factor to get DE since they're corresponding sides, as you can see over here. They're corresponding sides. And so 3 times 3 over 2 equals 9 over 2. And if you simplify that into a decimal, you're going to get 4.5. So our final answer is that side DE equals 4.5. Alright, so practice question number 5 says, will the following side lengths produce a triangle? And the side lengths are 11 centimeters, 9 centimeters, and 3 centimeters. Okay, the correct answer to this question is yes, these 3 side lengths will produce a triangle. And we can calculate this by using the triangle inequality theorem, which states that if the two smallest side lengths added up is greater than the largest side length, then a triangle will be formed. So here we have 9 plus 3, which is the two smallest side lengths, so we have 12, and then the largest side length is 11, and 12 is greater than 11, so yes, a triangle will be formed using those 3 side lengths. Alright, so practice question number 6 says, is an equilateral triangle in which every angle measures 60 degrees unique? And the correct answer to this practice question is no, it would not be a unique triangle. So a unique triangle means this is the only triangle that can be produced with these angles and these dimensions. And so with the triangle that has each degree measure is 60, the angle measures would obviously stay the same, but the dimensions can be changed. For example, this could be 1, or it could be 2, or it could be 3, and all of the side lengths could be changed, and we would still have a triangle where all the angles measure 60 degrees. So no, it is not a unique triangle. Alright, the final practice question of this video says, what is the maximum amount of right angles a triangle can have? The correct answer to this question is 1 right angle. So if we think of a triangle, we know that all of the degree measures can have to add up to 180. So if this is A, this is B, and this is C, A plus B plus C has to equal 180. And so if two of the angles are 90 degrees, then it would be 90 plus 90 plus C equals 180. And so this would mean C equals 0, and that wouldn't be possible. But if we had one right angle, we would have 90 plus B plus C, and so equals 180. And so in that case, B plus C could add up to 90, which is definitely possible. But if we have two right angles, it wouldn't work. So clearly the maximum amount of right angles we can have in a triangle is just going to be 1. We hope that was a good review of some geometry topics. If you still need some extra help, you can look in the description box for some links for further resources. Finally, if you enjoyed the video and would like to see more of them, please like and subscribe to the channel. Thank you.